So we're here with Nathan Paulsberg and Dale Abernathy, both professional firefighters and technical rope rescue experts, as well as Sprat Level 3 operators. So we'll go through a full raising and lowering operation with a live load on the tripod. All right, so we're going to have Dale as the winch operator, and Nate is going to be entering a simulated confined space here. So Dale's going to go through the lowering process, which is as simple as turning a knob. And then we will switch over to hauling and bring him back up. And the key benefit there that we're demonstrating is that there's not going to be any reset in the hauling side of things. And there's no switching of components or gear sets between a haul and a lower. It's all one device, one place. Okay, so you ready to lower, Nate?
Ready.
Go ahead. Okay, that's good, Dale. So when Dale stops, there's no reason to have to dog off the rope. This actually creates a full strength anchor because we're using essentially a advanceable tensionless hitch on the winch itself. So there's no knots to degrade the strength of the rope, so we call it a full strength system here. Everything is locked off by the Lokhead. And so just on the lowering, all Dale is doing is moving the knob to control the friction to allow for descent. Now we're going to switch over to a haul. Again, going counterclockwise with this one, it's really easy for me to retrieve a live load using the 40-to-1 mechanical advantage. If I needed to make that a faster retrieval, then I can go into the 13-to-1 where it's less torque but faster rope advancement. So I may have to work a little bit harder, but we can really move some rope much quicker. Now that he's near the entrance, Dale, go ahead and let me know when he's at the entrance.
About 5 more feet.
5 more feet.
Just slow raise.
All right, slow raise. Now I'm gonna switch back to the other gear where I have a lot of control. Now we have visual contact with him and we wanna make sure he clears that opening without any obstructions.
Head is at the hole.
We've got clear eyes on him. All right, Nate, I'm gonna switch back to a faster raise. So we've gone through the winch operation manually. We're gonna lower Nate out through our confined space entry here. And then we're gonna switch over to a powered-based retrieval using a drill in the winch. At the window. 5 more feet. We're down. Okay, so now we're going to switch over to hauling. And instead of using the crank, we're going to implement an AC powered drill. This can be done with cordless models as well. So, okay, let me just check. Nate, ready to raise? Go ahead and raise, Dale. Five feet to opening. At the opening. Breaching the hole. Okay, so you notice Dale started out in a slow speed, which means that he was driving it counterclockwise. Once Nate was comfortably with a load check there, he switched up, went to the higher speed for a faster retrieval. And then when we get towards the opening where there could be an obstruction for this operator, he went back to a slow speed for ultimate control. When using the drill, really this is something that would be a tool utilized by shorthand rescue teams where you may not have the manpower you know, say this is more than a 30-foot haul, Dale's going to get pretty tired after cranking the winch for 400 feet or so. So in this case, we can easily plug in an AC powered drill or cordless battery operated drill. We recommend above 18 volts if you're going with a battery operated. And using a right angle drill is going to help you to manage any torque that the drill can put into your body when it transfers off the winch. So really the drill is an accessory to the winch that can help in a short-handed rescue, reduce fatigue, increase the overall speed of response and retrieval of the load. A key factor of using a drill is always having someone maintaining a line of sight with whatever that load is, be it material, live load, or rescue load. Since Dale is using the drill, he doesn't get the physical response of what the handle input force is doing. It's a very sensitive input force when he's using the handle, so he knows if Nate has come against an obstruction. With the drill, that's not quite as easily defined. So when using the drill, it's anytime there could be a gap in communication, we always want to have somebody with a clear line of sight of the load to be able to communicate with Dale directly in case our comms go down or in case loud noises pick up in whatever setting we're in and we can't get clear communication. Unless you're using an intrinsically safe motor, meaning a sparkless, brushless motor, self-contained, explosion-proof, then basically that's going to be an environmental factor. So sometimes we may be in a factory that does flour or something, some sort of particulate that if it were to ignite, you can have an explosion. So anything that would introduce a spark into what would be a volatile environment, we would not want to use the powered option at this point unless it's an ATEX rated, intrinsically safe power head, which is available. There are plenty that run off of pneumatics, hydraulics, and there's plenty that are brushless and sparkless electric based. All depends on your site, your tool setup, and what the environment's going to allow you to do. So here we're going to demonstrate the soft attach or floating anchor. The mounting plate in its own right is a multi-directional rigging plate rated at 28 kilonewtons in any direction. And so we've established an anchor off of our high point, being the beam, because that was the most readily available structure. And to limit any rotational aspect or wobble, if you will, in the winch, we've just tensioned it off using some positioning devices. So why don't you go ahead and get rigged, Dale? So same thing, always clockwise wraps, with the last wrap progressing through the self-tailer. So go ahead and let a little slack out. And see how Dale had to actually disengage the self-tailer to manage the lowering. Since that can introduce a little bit of human error, what we always do when using this for live load applications is use the rigging plate to your advantage. Use a backup device of your choice. That way, if something were to happen and inadvertently untail this rope, we're going to arrest any rope advancement right there at the spot versus the load continuing downward. So go ahead and re-engage. And so once Nate puts his weight in the system and the system is tensioned in a singular plane, everything becomes much more stable. So go ahead and give it a couple of cranks with the handle. So you can see that this is a quick and easy setup, but it has a little bit of wobble to it when it's floating. And so one of the things that we can implement there is introducing a power head. Go ahead. And since the power head doesn't give you that lever arm to actually start to wobble the winch, it keeps everything very stationary. And as best practice, what Dale is doing is a great step. So he's actually going to tether the drill to the plate. In case he were to have an accident and drop the drill, we've limited any dropped items. So same thing, we have 2 speeds. So now we're actually just going to be using the direction of the drill to engage those speeds. So it really cannot get more simple than that as far as hauling through a winch. All right, so now that we've gone through the operation of the Lokhead through the demo on the tripod, you can see the clear difference in the standard self-tailing jaw versus what the Lokhead self-tailing jaw provides from a safety perspective and a controlled lowering perspective, with that self-tailing jaw being totally adjustable for the friction descent. Whether you're using it in a manual operation, a powered operation, you can see how it really simplifies the whole system, cleans everything up, and really maximizes the efficiency and the potential of a rescue crew. For more information, you can visit www.harkenindustrial.com. Beyond that, stay safe and thanks for your service.